Hello, so welcome back. In this tutorial I'm going to go over optimizational tips for Clickteam Fusion 2.5. Now, when it comes to the Fusion 2.5 runtime, the core runtime, it has evolved so much over the years, even stemming back to when Multimedia Fusion 2 was released back in 2006. We had a core runtime there that was solid, robust, and it was flexible. Now, looking back 11 years since the release of Multimedia Fusion 2, the core runtime has come a very, very long way. In the transition from 2 over to 2.5 back in 2013, it took a monumental step in terms of speed, performance, durability, a whole host of things. And what happened is when the base product came out as Multimedia Fusion 2 in 2006 and we had a solid, robust runtime, it wasn't necessarily optimized for 2013, but it was optimized for 2006. So mobile technology started evolving, Flash was more in use, HTML5 started coming along. Clickteam knew that they had to revamp the engine, and there was room for error in there for them to do that, and that's what they did. And even though we had a solid product in Multimedia Fusion 2, Clickteam Fusion 2.5, with all the performance enhancements, there was a lot that went on behind the scenes in the core runtime, such as processing speeds for values, global values, strings, list objects, that kind of thing. Things that you wouldn't really notice with the human eye. There were some real in-depth tweaks that was made by Yves and Francois, and then Francois ultimately integrated physics using Box 2D as well into Fusion 2.5. The user interface also got a bit of an update as well on a couple of things, but the fundamental changes that needed to be done were done in terms of optimization, because as developers were getting more experienced, I mean, Niffler's brought a lot of that to the table himself when he developed the Knit series. He was using events in a way that up to then, at that point, people never really used. A lot of people before Niffler's and Knit Underground was released were using them events, but not in a solid commercial game environment. They were just showing off their advanced skills with Multimedia Fusion 2, which is fine. But then when Knit Underground came along and Niffler's was doing all this great stuff, Clickteam kind of realised, hang on a minute, we can do even better with this. So, behold, 2.5 was released 2013. It's still being developed on today. I can't believe it's nearly 4 years since the release. Is it 4 years? It might be 4 years from the internal beta that was released, but it was either 2013 or 14. But either way, it's gone so fast, and over these last three years or so, 3 or 4 years, 2.5 is still getting today performance increases. There's a lot of work that goes on behind the scenes. I see it all, I test it all. There's a lot that goes on, then all the individual exporters. But back to the original topic of what this video is all about, is me trying to show you just a few things that I do pretty much on every project that I work on, because every project that I work on, I always bear in mind that there could be cross-platform compatibility issues. Then I have to also bear in mind that performance varies widely, whether you're developing for PC, whether you're developing for Mac, or whether you're developing for Flash, Android, iOS. It doesn't matter. What you need to do is you need to start to learn to adapt in your mind how you approach game design in Fusion 2.5, so that when you do come up to, if you're developing a PC game that looks really good, and then all of a sudden someone goes, well, are you gonna make an Android release? The last thing you want to do is look at it and think, wow, this is going to take me months to optimize it for Android, because I've only been optimizing it for PCs that have top whack graphics cards in, that have 2 gig of DDR5 on them, and you don't want to get yourself in that position. So from the off, when you're developing your games, if you can from the start just factor in a few key elements towards your game design, then hopefully everything should smoothen itself out. If I develop a game for PC platform, I just bear in the back of my mind that one day I might have to port this to Android or iOS, Flash, HTML5, or even the Xbox. So what I do is I factor all these into the game design, how I approach the game. It's just fundamental stuff. So I'm doing this video on a whim. I haven't really planned anything because I just want it to be able to just flow out the way I normally would approach you know, these kind of routines in Fusion 2.5. Now the first thing I am going to jump on is your use of active objects in Fusion 2.5. Now Fusion 2.5 is so capable of doing the same thing in so many different ways, and this is great for the user, because whether you're a beginner, whether you're intermediate, or whether you're an advanced programmer, there's numerous ways everybody can achieve the same effect. However, there are efficient ways and inefficient ways to doing it. What I'm going to concentrate on primarily in this video tutorial is how to use specific objects, how to control the properties of specific objects, setting up the game design itself, because that is the biggest factor for memory management and handling in Fusion 2.5. Now even though I say that the runtime is heavily optimized, you've still got to optimize your game. The onus is still on you as the developer and the designer to still optimize your own game. You know, you can't. For example, over the years, I've seen so many people importing animation frames that are huge, like 512 by 256, and then this animation frame is like 54 frames long. You know, that's a lot of memory. And then when they put it on their Android device and it's running at 5 frames a second, they then jump on the Clickteam forums and start umming and ahhing, saying, "Oh, you know, this product's no good. You know, it doesn't run my game." Blah, blah. All it takes is for you to approach the design in a different manner. You've got to remember, you're working with a tool here that requires your input. You know, you don't press a button and it magically creates a game for you. You're creating the game, so you've got to go in with this mindset that you've got to work with the tool. Active objects are probably the biggest factor when it comes to objects in Fusion, and the most dynamic object that could affect the performance of your game. So what I tend to do is, I've covered this in previous video tutorials, what I tend to do in this day and age is, rather than using global values and global strings in any development that I'm doing, whether it's an application development or a game development, I use active objects as opposed to global strings and values, because I want to keep this bit clean. I want to keep this clean throughout development. I don't want to have, you know, 312 different global values for different settings that I'm using. So let me give you an example of this. What I would tend to usually do is maybe have primary values inside a global value. So what I have, for example, user score. For a global string, I would have username. That's pretty much it. If I have coins or anything that the user's collected that I need to save and I need to load, then what I do is I create an active object, I place it outside the frame area, and then I use this. So I can relate to objects inside of the event editor rather than global values all the time, and it looks good. It looks good when you're looking at your frame. It's less confusing. So for example, if our players say he can collect coins and power-ups, then I would call this object something like inventory, like that. And then I would have, you know, power-up 1, but obviously you'd rename these to what your power-ups were, power-up 2, power-up 3, and so forth. And then I would have a count of what kind of power-ups they've got in there. Now you can either approach this with two ways. If you've got a power-up that the user can collect once and then use once, you would just use like a flag-based index of 0 or 1. 0 indicates that the user hasn't got that object, and 1 indicates he has. Now if it's an object that the user can collect multiple of, then you can just add to this. So does the user have 1 of power-up 1? Does he have 3? Does he have 6? 67? And then when he uses 1, you can just subtract 1 off in the events. And then same with the global strings. Also in here we could have stuff like coins, so how many coins he collected. We can have individual level scores. So back to the design side of things. What's important here is the way Fusion will handle this. Now, you've got to remember, this is not a visual object. The user's not going to see this. It's ineffective on the screen. So I place it outside the play area. I then uncheck all these. I don't need Fusion to use fine detection on it, because there's no collisions with this object. This object I'm just using to store values in, and I can disregard destroying object if it's too far away from the frame, and all this kind of stuff. I don't want it to destroy at any time, because I need it there all the time to reference values. So I don't need Fusion to check, you know, on every tick whether it's too far away from the frame or not. And then I can also jump to the display options. I can uncheck visible at start, because the user's not going to see it. I can uncheck save background, and I can uncheck transparent also. I don't need any visual effects on it, and these here are activated by default. Uncheck them. When it comes to Android particularly, unchecking these properties will make a massive difference. If this active object is not an object that the user is going to see ever, you're just using it for value storing, get rid of all these, because these tiny differences soon add up, you know. Let me just open up. This is one of my slot machine engines. You might have seen it advertised around on the forums a little bit. But if I just open up my Top Treasures slot machine, this is super heavily optimized. But as you can see, this is the slot machine game. Let me just run it so you can see how it works. So it's your typical slot machine. You have, you know, the amount of coins you've got here. This is a level indicator. It's on infinite at the minute because it's not on mobile. You've got the amount of lines that you want to play on the screen, and then how much you want to bet per line as well. And then you just spin. You spin and hope for a win. There's a lot more to it, but this is the core engine. Now, in this engine, I had to develop it, and in mind I knew it was going to be cross-platform: Android, iOS, Flash, HTML5, PC, Windows tablets, Xbox. I knew I had to optimize it, so I did. And you can see I've got a lot of objects. For such a small one-frame game, there's a lot of objects. And it took me a long time, but I heavily optimized it all. The optimizations that you do might seem tedious, but believe me, they're not. When it comes to Android, some devices out there is absolutely thousands of different Android devices out there, and the last thing you want is a user coming onto Google Play and leaving a negative review because your game runs too slow on their device. So you really want to cater for as many devices as you possibly can. When I first started developing the slot engine back in 2013, it was alright, it ran good. Performance wise, it was touch and go, it was hit and miss. But obviously that was still back when the Android exporter was still early in development as well. So as that's progressed, my development and design of the slot machine has progressed as well. Now, as you can see, going back to my original first design point, here I have a slot configuration object. I don't really have too much in here. I mean, this is nothing. There's 25 global values there and 4 global strings. Now, if you look in the slot configuration, I don't know how many there is there. There's 24. So if I'd have put them in with the global values, imagine how big the global values would start getting. I've got all these other objects here as well. Now, you can see I've got like minimum lines, that's the minimum lines the user can play, the amount of maximum lines the user can play. I've got offsets for the spinning of the reels. I've got wild fives. I've got all these different configuration options that I can use. I can put it into debug mode and whatnot. Now, you can see I've unchecked these objects because the user doesn't see this object. I'm just literally using it as a container to store values. So I can uncheck all them. It doesn't need a movement, and I don't need to do any fine detection on it. So the same principle goes for all these. I use this object for my free spins, so I know what the multiplier is going to be. I can activate the free spins group, which will then take care of the free spins for me. Then I've got like a user configuration as well, where it stores the user balance. the lines, the stake, the XP level, and the username. And all this data gets saved. It's encrypted and then it's saved to the user's device. Now, if I was to develop this online and I really needed 1000% security on this, then I would develop it with a server, which I have done. I've done that for previous clients as well. But this is just a play for fun game. So I just save the data. I just put some simple encryption on it, and then I save it to the device. But as you can see, how it all works now. Little things like the animations and things like that. Most of them aren't visible at the start. There's a lot of things that I don't create at the start. There's a lot of things that I do. Now, this big win image here, if you take into consideration the size of it, once I'd finished my design and I was testing it, it was when I loaded the frame up, it loaded within a second. So I had a bit of room of error to play with, room for error even. So what I did was I preload these at the beginning of the frame, and then I hide them. That way they're already loaded, because the last thing I want is when the user's spun the reels and a big win comes in, it then takes 5 seconds to load up this animation. I don't want that, so I want to preload it at the beginning of the frame. So again, it's all about design, your approach to the design. It depends what kind of game you're developing and what you're doing. But again, with these, I do the same with these. I create them all at the start. I'd rather have it take 2 seconds to load at the start of the frame than stop halfway through the frame to load additional objects. So that's one of the fundamental things you should do if you're going to use data objects like this. I just use them purely for storage. It's so much cleaner and more friendlier. In the events, I can work, if I just look at the events for the slot machine, you can see now I'm working with these instead of global objects. I'm working with instead of global values, sorry, I'm working with actual objects. So I can do lots of different checks and settings, and when I'm doing conditions, I can compare values from the object. Rather than having a big list of 350 global values to choose from, I can think, right, hang on a minute, this next event is going to be something to do with the slot configuration. So I know I'm clicking on this object, and then I'm going to compare one of the values from the slot configuration. Just little things like that. It's just so helpful when you're developing in Fusion 2.5. When it comes to the application settings, there's a whole host of things that you can do with regards to optimization. For example, developing at a lower resolution is always going to have an advantage over developing for a higher resolution. This doesn't necessarily mean you have to develop your graphics at a lower resolution. What I would do is I would develop your graphics at the highest resolution you feel comfortable with, and then downscale them yourself before you import them in to Fusion 2.5. Now, if you know that your game resolution is going to be 800 by 480, don't bring in an image that's 1024 by 768 and then downscale in Fusion, because you put in strain on Fusion's runtime. Because as soon as you in here, whether it's at the start of the frame or it's always, and you're scaling the objects, scaling down is good, but not in real time. Whether you're doing it with anti-aliasing on or anti-aliasing off, it doesn't matter. You're still adding more overhead to the Fusion runtime. So what you're better off doing is, if you've got a graphic that's this big and it needs to be this big, resize it before you import it into Fusion. That's your best way to do it. Another thing as well, when you're importing into Fusion, is when you're importing artwork, what you do want to ideally be doing is importing again, it's all about the design and the approach to the design. If it's a backdrop object that doesn't really have much clarity and the user's not really going to see it, import it as a JPEG and have a transparent colour. That is the quickest way you can do it. The second you import a PNG 32-bit with alpha, you're causing more strain than what's needed. The only time you should ever really use PNG 32 alpha is for your character or something in the level that needs clarity, sharpness, and you know, you just really want it to stand out to the user. If it's a background of trees that's this big, that's just going to keep scrolling around the screen and the user's not really going to pay much attention to, then just export it as a JPEG. Knock out the background color with one color, a single color. Instead of having an alpha channel, just have a transparent key. That's all you need to do. When it comes to mobile, it's these kind of things that are, you know, you really need to optimize for. I mean, I've helped out so many people over the years. You know, when they're developing the games, you know, I've had people come up to me and say, Danny, you know, I've developed this PC game, and now I've got a sponsor, or I've got a publisher, and they want me to port it to Android, and I've helped them out, you know. And the biggest thing I used to say to them is, do you need this? And do you need that? Does it really need to look this sharp? Does that really need to look? No, it doesn't. Right, okay, well, re-import it back in, get rid of the alpha channel, re-import it back in. You don't really need it. What else can we go off from here? Some of these settings are quite important to the runtime, because you're helping the runtime and you're helping your own game design as well. When you're using these kind of objects. Now, when you're using Android, for example, you have a lot of properties that you can tweak on Android. They're all in here. Again, some of these tips, like this one coming up right now, is not an across-the-board piece of advice. Each project that you work on and develop will be a lot different. However, it's always best to develop at the highest API that's available, which is 24 at the minute. I think 25 is available, but it's not as much supported as 24. This was set to 20 because I haven't worked on this game for nearly 2 years. So always build at the highest API that you can. If you want to get rid of the your game doesn't support tablets message on Google Play, then you need to be developing for at least 3, and your target should be 4. That way, you know, Google will think that your game is optimized for tablets as well as mobile. If you drop below that, it'll still work on a tablet, but it'll just display a message on your Google Play Store listing saying it might not be compatible, which is, you know. You can select whether it requires a GPU or not. What else have we got here? This is a key thing here for optimization. It's such a big description. You can force play from disk for your sound effects. Now, there has been, again, when it comes down to sound effects, there's so many optimizational things you can do before you import your sounds into Fusion. Now, back in the golden days of 2006 and way before that, even like way back to the Games Factory, you could import WAV files. And WAV file is just a raw format of sound that typically has left and right channels and for stereo, and then you've got an abundance of different quality settings. It's just insane. What the point I'm trying to make is, you can have a sound effect, just say when a user collects a coin, and it's just like a little ding sound effect. You can have that sound effect in a WAV format that will be 18 megabytes, and you can have the same audio file with the same sound effect with pretty much the same clarity, without getting too technical, in an MP3 file that's literally kilobytes, 60 kilobytes, which is like a 98% difference. It's unreal. It's crazy. So don't start importing big WAV files in that are 40 meg and 50 meg. You're just crushing your application. And not only that, you're quite limited on the Android Play Store to what your file size can be. Your initial file size can be up to 100 meg. After that, you've got to do expansion files. So that means you're going to have to start coding expansion files into your Android application. It's not what you want to be doing. So your audio files, OGG is a good format to use. OGG is really good. And MP3. MP3 can be a bit tricky because of the legal aspect. If your game makes over, I think it's $100,000 a year or something in revenue, then you've got to split the profits with Lame. But you'll have to check all that out yourself. But what I'm just saying is, just don't start importing big audio files. It's not worth it. If you've done that and you've optimized your audio and you're still having issues with your audio, you can do a few things like up here in the sounds under data elements, you can still use options like preload, load on disk and play from disk. These are compatible with all the runtimes, not just PC runtime. So you can still preload all your audio into memory before the sound's even called, or you can use load on call, which means it'll only load that sound into memory once Fusion requests it. And you can use play from disk, where it won't load it into memory at all, it'll just stream it straight from the disk that it's on. In terms of disk, when they refer to disk, what they mean is in terms of Android or Apple, the game will be, when the user launches your game, it will unload the files temporarily to a temporary folder, so it will just stream the file straight into Fusion and play it. Play from disk is not typically the best option. Preload is always the best option if you've got small files. If you've got a WAV file, if you've got an audio file that's quite long and it's quite, and you need it to remain crisp and clear, then I would play from disk. However, rather than going through each individual sound and doing all this, if you just want to specify a time, then you can. Usually the longer the audio file is, obviously it's going to be a bigger file, so you can just specify a time here. If the sound file is greater than 5 seconds, then don't preload it, don't do anything else, just play it from disk. Which is a great method, because that means then it will only play it from disk once the sound effect has been called via the events. So it won't be preloaded into memory, thus saving more memory for your gaming application. Let's just put these back down a little bit more. What else have we got here? Your display mode is very, very important. Majority of Android devices now are running 2.0 at least by default for OpenGL. And a lot of them now are starting to run 3 as default. ES 1.1 has been left in Fusion for compatibility. There's still some older devices that only use OpenGL ES 1.1, which was basically the first revision of mobile OpenGL. So it depends who you want to target. If you want to decide on a cut-off point and go, you know what, if you want a device from 2012 or before, you're not going to play my game, you might as well just use ES 2.0. But if you do want to support that small minority of devices that are still running some of the first chipsets for Android, then just select that. But ideally I would just stick with 2.0 because that's what's in it anyway. This is a huge factor, image compression, and I think this is available for iOS as well. I'm not 100% sure, I don't have the exporter installed on this laptop. But this color reduction is hugely important, because what it does is it takes all the images that you've imported into Fusion, even in the animations and all the active objects, and it compresses them even more. Now it can cause a little bit of havoc with some of your graphics, because you can look at some of your graphics and once you've built it to Android and go, oh, that doesn't look very clever, it doesn't look very good. So what you can do is, this is what I do. I always put color reduction on, always. Then what I do, if I have a graphic inside Fusion, that I don't want to apply that object to, I can take it off. So if I create an active object here, let me just change this to Android. There we go. So if I click on this, so just say this object, I want to put image compression on all the objects, but I need this to stay crystal clear when it comes to the graphics, then I can select none in the image compression. So that default option that was on, which is wherever it's gone here, it's going to apply to all the objects, then it's going to come up to this object and not apply any image compression, so the clarity will stay for this object. So if you can, always try and keep image compression on, and if you see an object in your game where you think, oh, that needs to be a little bit more clear than what it is, then just go back to your frame editor and unselect the color reduction or the default from there and just select none. So Fusion knows when it's building the application to leave that one alone and don't compress it any further. Stretch to fill, this is debatable again. Depends what kind of game you're developing. It's all down to you. Anders wrote a tool which you can find on the Clickteam forums which explains how these display modes work, so I highly recommend that you check that out. Smooth resizing. Smooth resizing basically means if Fusion has to stretch the frame to fill the screen, does it apply any anti-aliasing? And if you've said yeah, that means you've checked smooth resizing. The best thing to do with that is when you're testing your game on an Android device or an iOS device, just try it with and without that and see what kind of difference you get. Usually it's quite minimal, but it can add, you know, with that checked, it can add more overhead to your application. Apart from that, there's not really much more in there that you can tweak, really. You've got things like your frame rate. This is not really effective for anything but a PC or laptop, well, a Windows runtime basically, and the Mac runtime. I keep these checked because some of these can be applicable, especially to Android. So I would definitely keep them checked if I was you. That's the best way to handle it. VSync, definitely put VSync on if you're experiencing VSync issues. If you're running your game and you see lines, you see on the screen, you see that there's a line running through the graphic, I would definitely put VSync on. This usually applies to something that's fast-paced, like a platformer, or if you're shooting through space, or even on my slot machines where the reels spin, you can see a VSync issue there, so I had to put VSync on. But VSync doesn't actually add much more overhead to your application, so it's perfectly fine to keep that on. So when it comes to the exporters, particularly Android and iOS, they are very touchy as long as you can go in with this mindset. For example, using a string. Now let me just tell you that Fusion, the standard Fusion runtime uses the CPU. So what happens is it'll draw an object to the CPU, it'll draw it to the screen, and it will stay on the screen until something changes. When it comes to the Direct3D 9 runtime, and when it comes to the exporters, all the exporters are OpenGL based. Well, majority are OpenGL based. So what happens there is, if your game's running at 60 frames per second, that means that the Fusion runtime has to render everything on screen at 60 frames per second, and this goes for text string objects as well. If you've got a string object in there, even if it's just somewhat simple like the user's name, so like username or my username, what you don't realize is when this application is running on an Android device, it is redrawing that string 60 frames per second. It's redrawing it 60 times a second, which is a lot. It's a hell of a lot. So what my point here is, if you don't need to display it, don't display it. Like for example, if you've got what would I do? If you wanted to display the user's name in the game, don't display. If you don't need to display it all the time, then don't display it. Just to be honest, I wouldn't even hide it. I would just destroy the object, just completely destroy it. If you do need to show it, like maybe you'll show it when the user pauses the game, then in your events just have an action that, you know, once the user has paused the game, then create the object, create it on the fly. It's going to be the best way to do this. Create it on the fly, and then you know, set the text, change alterable string, and you know, to the player's username, whatever, and then when the players unpause the game, then destroy it, get rid of it. It clears the memory, it helps with the garbage collection, it clears it from memory. If the user doesn't need to see it, don't let Fusion draw it. Don't even hide it, because sometimes hiding objects it's not helping with the performance side of things, it's not helping with the memory side of things. It just because you can't see it on the screen doesn't mean it's not there. Doesn't mean that it's slower. Like for example, if you're using a counter object and you're doing always add 1 to counter, I don't know why you would do that, maybe using a bit of delta time or something like that, then you can see that it's always adding 1 to the now for example, if you're using this counter just for something in the events, like if the counter is greater or equal than 34, then create an object or whatever. If the user doesn't need to see this, then set it to hidden and get it off the screen. Don't just hide it. Don't just uncheck visible at start. Actually set the counter to hidden rather than just unchecking visible at start. So basically the principle is, if the user doesn't need to see it, it doesn't need to be there. If you can call the object at a particular time, then call the object, create it, position it, and then when it's done with, destroy it, get rid of it. It doesn't matter, because it will only destroy the object at the end of the loop anyway. So it's just little key things like that. So it will draw this object 60 times a second. It will draw the string object 60 times a second also, which is why I highly recommend using blitting if you possibly can in Fusion 2.5 over strings. The Android exporter particularly, it's not a fan of strings. It's just because of the way the routine is in the core runtime, the way it draws the strings to the screen. That's all it is. So I would highly recommend using active objects or blitting for displaying any text in game if you can. It doesn't really matter, you can still use string objects. Just try and be a little bit scarce with them. I remember when James was first developing the Android exporter way back in 2011, 12, something like that, and I was testing it and I had all these strings on the screen. I was like, wow, why is it running at like 2 frames a second? Don't forget, this is like 6 years ago. And I disabled all these strings and the game went straight back up to 60, so it was quite evident. Obviously we've come a long way since then. Strings are a little bit more optimized, but I'm just giving you an example of how you can see how I've come to see these core differences in your approach to the design with particularly Android. I've developed quite a lot for iOS, but I've not really developed as much as I have with Android. If you've checked out any of my previous tutorials, you'll see that I'm a massive advocate of using groups, especially for fast loops, and it's not in terms of performance, it's just literally for keeping your event sheet clean. And clean is the operative word there, because so many discrepancies can happen that you overlook. You could write 600 event engine, and you can test it every X amount of events and everything goes fine. Then you get to 601, something goes wrong. It's not the 601st event you've just created, it's something way back, but you don't know what it is, and you're spending so much time rifling through event code. Check out the Ultimo Slots one, the Top Treasures one that I've done. It's so linear, everything is so linear, it's let me just, so if I close all the groups, you can see my engine runs top to bottom. So I don't really reference any group up here from down here. If I know it's got a chance to be executed, it'll be executed in one of the conditions which is above the event group. If not, then it won't. And the reason for this is, if you've got a group that's up here that has some conditions in when you activate it, and the event to activate it is down here, it's got to wait until it's processed all these events before it flicks back to the top and comes round to it again. I can't afford for that to happen in this type of game. It needs to be working in a linear fashion from top to bottom. I work it in steps. I have step 0, which means the slot machine is doing nothing, the user's not pressed anything. Then I have the user presses spin, and it runs through a sequence, and it runs through steps. So I go step 1, do this, step 2, do this, step 3, do this, step 4, do this. Then I have crossroads. I'll have step 5, do this, but if this happens, open this group. If this happens, open that group. And at the end of them 2 groups, I then have a close that goes to step 7, which then keeps going down in a linear fashion. So that's just the way I had to make the slot work. Obviously your games will vary quite differently, but it's all about the approach to the design, not just visually, but also to your events in Fusion 2.5. Also, if you've got a real big graphic that you don't need to display, I really highly encourage you to use load on call. So basically this will just load the object when it's called in the event editor. So if you have a really big boss that you've got lots of animations for, but he doesn't appear till the end of the level, and it's going to take the user 2 or 3 minutes to get to the end of the level, don't preload it at the beginning of the frame. By default, Fusion 2.5 loads all the objects in that frame at the beginning of the frame. It loads it all into memory, and that's so that it can put it all on screen and it's all there ready to go and whatnot. But if you've got a level that's going to take the user 2 or 3 minutes to finish, and then the boss comes in at the end, then what you would do is select load on call under memory options for that object, and that will stop Fusion from loading it up at the beginning of the frame, causing even more delay to your frame loading. Now, if you experience a situation where the user gets to the end of the level and then the load on call kicks in and it starts to load up the boss, and you see a bit of an issue because it's taking like a second or two to load, then what you're probably better off doing is unselecting load on call, and just putting a loading screen up at the beginning of your frame so the user knows that it's loading all the graphics in. Because one issue you have with the Fusion runtime is you can't accurately project the loading of the frame. You have to do it by visually displaying the loading of the frame. There's an example file on the Clickteam forums that I did a few years ago that explains this, and it shows you how it works. If you search for preloading or something like that, I think it's under that. But the basic principle is Fusion by default will always load. It'll come to the next frame and it'll go, right, before I draw the frame, give me a list of all the objects, and it'll load all the objects up into memory, and then it'll start drawing the frame out. And this is where the issue comes in. People don't do loading screens, so all you have to do is create a simple graphic on the frame before the actual game frame, and that graphic will stay on the screen until the next frame is completely preloaded. And as long as you've got the word loading on there, then your user's not going to think, oh, this game's crashed, you know, because you can actually see that it says loading, so it knows that the next level is loading. In your game, no matter what platform it's for, if you don't need fine detection, take it off. Get rid of it. Using fine detection on hundreds of objects can cause a big overhead to your game that you don't necessarily need. So if you take this object for example, if I wanted to detect if it touches this corner here, because you can see this is white space here, then I would need to have fine detection on. However, if I just need to detect that there's a collision with the bounding box, I can take fine detection off. So if it's a square, get rid of it. If it's a circle, and do you really need fine detection on? And if you do, put fine detection on. If you don't, take the fine detection off, because it will start mounting up. These little things are so small, but they can grow so big at the same time exponentially, and you won't even realize it. All these things are on by default. Destroy object if too far from frame. So if our frame comes over here and then this object is way over here, and Fusion thinks that we're probably not going to need it, it'll destroy it. Same for this. If it's inactive, if too far from the window, this is subjective. Typically I would put no, and I wouldn't put this on. And the reason I wouldn't do that for any single game is because I would control via the events when an object's getting created, when an object's getting destroyed. So if I wanted to detect that the user's gone all the way over here and this object is all the way over here and I don't need it anymore, then I would detect that through events and I would just destroy the object myself. I wouldn't let Fusion handle that for me, but that's just me. If you're a beginner, I wouldn't recommend that. If you're intermediate or you're advanced, you should probably already know about this, but that's when it comes to the approach for the design, whether it's a platform game, a space game, it doesn't matter what it is, you should try and fully control your game when things are spawned and when things are destroyed, based on whatever criteria or conditions you want to stipulate. Aside from that, I can't really give you any more insight right now. I can't really think of anything that's going to affect the approach to design. I'm not saying that any of the things I've discussed are solid in concrete and you should follow them. I think you should for a majority of projects, and some of them you can probably disregard. It all depends on what type of game you're developing. There's all sorts of things you can do, but you just got to remember at the back of your mind that you're working with the Fusion 2.5 runtime. You've got to work with it. Don't work against it, and don't work for it. Work with it. The engine, the core runtime is there. It's heavily optimized. It's a really fast engine. Just work with it. Work with it. Just try, do these simple things that you need to do to make things a little bit easier for you. And definitely a lot easier in the future if you decide, hang on a minute, I'm going to have to port this over to Android. It's going to make your job a hell of a lot easier. But yeah, that's pretty much it. I might follow up this video with another tutorial video if I've missed anything out. I've got a strange feeling that I've missed out quite a few things. But that's all I can think of off the top of my head right now. So I hope you find this video useful. If you do, subscribe. Check out the website fusionrad.com, and I'll see you in the next tutorial video.